So does this seem familiar? Open the fridge, take out the jug. The date on the bottle was 3 days ago. Look, I'm not going to drink that. Well, maybe you should. Food waste is a huge issue in the United States. Somewhere from 30 to 40% of all food purchased in the United States never gets eaten. And part of the reason is because of those darn dates on the labels. Most date labels have to do with quality, not with safety. For milk, it's pasteurized, so it's going to be safe because of the pasteurization process. We wanted to figure this out more, so we brought some consumers into the lab, and we took those date labels off of the milk jugs and had them sniff it, and then decide if they would dump it or keep it. And not surprisingly, many fewer people decided to dump the milk after they didn't have the date label on there. So the next time you're in the fridge thinking about this, remember those date labels have to do about quality and not about safety. And you should think twice, sniff, and then decide whether this milk is good to go or good for the garbage. It'll be your choice, but choose wisely.
To get started, I'd like to remind us that sustainability is a global challenge. The root of this challenge is the development of our economy. In a nutshell, we take materials, biomass, fossil fuels, metals, minerals, we extract them, we trade them, and transform them into goods, or we use them to create services. They're eventually disposed of in the environment as waste or emissions, and environmental impacts occur along all stages of this supply chain. Annual global extraction materials has grown over time, as you can see from this graph on the left, and growing at an increased rate. Consumption of resources for energy is just one of the primary drivers of this extraction. This transformation of materials into valued products and services has delivered enormous benefits in the form of increasing material living standards for many, as measured here by average per capita GDP, or gross domestic product, and as you can see on the right, reduced poverty rates. However, these gains have been very uneven. There are still substantial ongoing inequalities across the world, and little under half of the world's population is still living on $5.50 or less per person. Dramatic increases in greenhouse gas emissions have led to irreversible climate change and a radical destruction of our natural systems. Approximately 25% of animal and plant species are threatened, and around 1 million species face extinction, many within decades. The loss of biodiversity and wildlife habitat is having an increasing effect on the health of not just our natural systems, but our human health as well. In fact, it's a major contributor to the increased incidence of global pandemics, including the one that we are currently living through. These impacts largely occur outside the marketplace. In other words, they're externalities, as economists would say. They're not reflected in measures of material wealth, such as GDP, and thus GDP is not an appropriate measure of sustainability or of well-being. And of course, global population is still growing. The world population now stands at 7.8 billion. We're expected to reach 10 billion by 2056. We are clearly not on a sustainable path currently. So what is sustainable development? The Brundtland Commission report, called Our Common Future, came out in 1987 and famously described and defined sustainable development as, quote, development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And at a minimum, sustainable development must not endanger the natural systems that support life on Earth. So in other words, it's about preserving these natural systems for the future and for the future well-being of future generation. And it's about balancing our current consumption and our current impact on the Earth with these preserving the future systems for these future needs. So how do we do that? How do we know how much of a reduction of greenhouse gas emissions we need, or how much natural lands to conserve in order to become sustainable? What are the sorts of strategies or policies that we need in order to develop sustainably? There are different approaches to this question. I want to highlight 3 different approaches. The first one is referred to as strong sustainability. This approach asserts that human well-being is dependent on physical and ecological limits and maintaining those limits. It goes back to this idea that the Earth provides critical support life systems and services to humans. And so we need to enforce minimum levels of ecosystem regulation services. For example, minimum levels of soil organic carbon, pollinator diversity, climate regulation. Along with that comes maximum sustainable yields of renewable resources. For example, maximum yields of fishing and harvesting of forests. And finally, maximum rates of pollution. For example, greenhouse gas emissions and nutrient runoff, that we would cap these at maximum rates. And in doing so, we would respect what are sometimes called planetary boundaries. These are boundaries that are conceptualized as helping us to stay within a safe operating space for humanity with respect to Earth systems. You can see here on the left the image showing some of these planetary boundaries and how in red we have exceeded some of them already. Biodiversity loss and nitrogen pollution being two, and we're pushing up on the climate change boundary. The idea here is that if we exceed these boundaries, we exceed thresholds, and the state of the system changes dramatically, and in ways that life as we know it will be substantially compromised. So sustainable development in this case would be development that meets or doesn't exceed these biophysical limits. The second approach is commonly referred to as sustainability indicators. And really here we harken back to the three pillars of sustainability. As Brent said, people, planet, profits, or what sometimes people say, environment, economy, and society. You've seen the commonly drawn three-circle Venn diagram that shows sustainability at the intersecting part of that. The most common example of this indicators approach would be the United Nations Sustainable Development Goals. 17 goals in total, all wrapped around these three pillars of sustainability, and a total of 169 targets within those 17 goals. Each target in turn is measured by one or more indicators. And so, for example, goal number 15, life on land, includes targets and indicators that measure the amount of forest land, wetlands, and other ecosystem, terrestrial as well as freshwater lands, to be maintained as part of these goals and targets. And so under a sustainability indicators approach, sustainable development would be defined as development that meets these sustainability targets. A third approach, before I get there, let me also mention that there is many examples of this kind of indicators approach, including here in Central Ohio, the Mid-Ohio Regional Planning Commission, or MORPC, has developed a regional sustainable framework based on input from their Sustainability Advisory Committee. They've laid out 5 goals ranging from energy consumption, natural resource conservation, as well as promoting economic opportunities, sustainable neighborhoods, and regional collaboration, and a total of 23 objectives and targets across those 5 goals. And they have a scorecard or a report card in which they are measuring using indicators for each of these, measuring progress. A third approach then is referred to as weak sustainability. And the idea here is that rather than focusing on a particular limit or set of limits that are targeting biophysical processes or systems, or rather than enumerating a lot of variety of different indicators, we're focused more on what some people refer to as society's productive base. And that is the idea that there are capital stocks and that maintaining these capital stocks over time is really what is important for sustainability. And so when we think of capital, we naturally think of things like manufactured capital. That would be the total goods and services that are produced over time and maintained over time, including things like machinery, buildings, roads, cars, any kind of durable product that you can think of, and fixed assets as well. So that stock of manufactured capital is one kind of stock, and maintaining that stock over time is one way of thinking about sustainability. However, just maintaining manufacturing capital is clearly not sufficient for sustainability. And so the idea here is that we have a comprehensive or inclusive approach to thinking about other capital stocks and the value that those provide to society. So for example, in addition to manufactured capital, we have human capital. Human capital refers to the stock of knowledge that we build up through learning and education and scientific discovery. And of course, the value of natural capital stocks too. Natural capital refers to the stocks of ecosystem assets, for example, from freshwater or from terrestrial systems, as well as the stock of natural resources that are not extracted, but that are in situ in their natural environment. And so if we add up all these values of these variety of different stocks, what we come up with is something referred to as inclusive wealth or comprehensive wealth. And it's the social value of all the capital assets in society. And it's the idea that we maintain this inclusive wealth over time that makes us sustainable. So we're not maintaining anything in particular, but in general, we're maintaining this inclusive wealth. And so from a weak sustainability point of view, development that maintains inclusive wealth over time would be considered sustainable development. So as you can see, there are many different approaches, or at least several different approaches to thinking about sustainability, and they vary pretty dramatically in terms of their approach. So let's explore some examples of how we would apply a strong sustainability and a weak sustainability approach to Ohio, and in particular to answering this question, are Ohio's lands sustainable? There are many strong sustainability targets that we can consider, but perhaps one of the best known in Ohio is the 40% reduction goal in phosphorus loadings into Lake Erie. Of course, toxic algal blooms in Lake Erie have increased over the past decades, and they threaten drinking water. They've had adverse effects on fish and wildlife habitats and populations, and of course on fishing activities and other recreational pursuits. A few years ago, through the Great Lakes Water Quality Agreement, the governments of US and Canada set an overall goal of 40% reduction in total phosphorus entering the Western Basin and Central Basins of Lake Erie from 2008 levels. In addition to that, they also set localized targets for specific watersheds where localized algae is a problem, including the Maumee watershed in Northwest Ohio, which is primarily agricultural. 40% reduction in spring total and dissolved reactive phosphorus loadings into Lake Erie. In this particular watershed, most of the phosphorus loadings is coming from fertilizer applications from agricultural lands, and therefore, a strong sustainability limit imposes changes in agricultural land management and use. And so we can ask, do Ohio's agricultural lands in the Maumee watershed meet the 40% phosphorus reduction targets? Well, just based on measured data averaged over time, here in the top bar, you can see the answer is no. We're in excess of the target total phosphorus or TP load, as well as in excess of the target dissolved reactive phosphorus load or DRP load. And this is averaged over time from 2005 through 2014. Of course, year to year, there's variability, and depending especially on rainfall and temperature, we may be a lot over that target, or in some cases we may have met it. But on average, we are well in excess of it. So through models of the watershed dynamics, as well as land use and land management, we can consider what kinds of land use and land management arrangements might reach this 40% reduction goal. And here you can see outlined in red some of those approaches. For example, converting cropland to grassland on a targeted 25% or targeted 50% of all the agricultural lands in the area, nutrient management on 100% of the agricultural lands, or a series of practices that are either targeted or random, including wetlands and buffer strips on targeted 50% of the land. Now, some of these are very extreme scenarios, and we would never in reality be able to achieve these. And so one of the big limitations of a strong sustainability approach is that it fails to articulate what the trade-offs are of meeting these kinds of land use and land management targets. In particular, there's nothing here about economic costs or opportunity costs to farmers if we were to somehow implement a policy that would achieve this level of conversion and change. And so the weakness of this approach is that it does not provide a full understanding for what the costs are of the various sustainability limits that could be imposed. So an alternative approach would be the weak sustainability approach, and to ask, are we developing in a way that meets a weak sustainability standard? Or in other words, is inclusive wealth being maintained or is it increasing over time? So we've done some preliminary calculations. One of my grad students here in AEDE, Brian Koltheis, has dove into this question and has some initial calculations. It's still very preliminary, but as you can see, what we've done here is we've calculated the values of natural, manufactured, and human capital, where natural capital is broken up into exhaustible resources, so this would include oil and gas, and then renewable land resources, forest, cropland, and pasture in this case. Manufactured capital is broken up into non-residential fixed assets and capital, as well as residential or housing capital. And human capital, again, is the stock of knowledge. It's approximated here by the years of education in total that Ohioans have received and the wages that they've received on the basis of that education on average. And so it's a value of our knowledge that we've invested in. Here we've done these calculations for 2 years, 2001 as well as 2016, and then looked at the change in that 15-year time period between the two indices and various values of these stocks. You can see then all the way on the right, the percentage annual change between 2001 and 2016 shows that we've had losses, not surprisingly in terms of the exhaustible resources as we've extracted those from the land, and slight losses in terms of forest, cropland, and pasture. That's largely because there have been declines in forest and pasture, slight gains in cropland that have made up for some of that. Now here we're reflecting mostly market values in forest. We're also reflecting some of the non-market values, including the carbon sequestration value of forests as well as the recreational services. And so one thing that we have to do further is to consider additional ecosystem services that are either lost because of these land uses or are gained because we've maintained land in certain uses. On the manufacturing side, you can see that non-residential manufacturing is where the biggest growth has come from, an average of 1.7% annually in terms of increases. And so overall, what we find when we add these up is we have an inclusive wealth increase on average of 0.78% annually between this year. And so we would say that we're modestly sustainable on that basis. Now, there are some limitations, of course, of this approach. I mentioned we're not fully accounting for all ecosystem services yet, so that's one caveat. But more importantly, even once we do that, we still won't be fully accounting for sustainability in a future sense, where this is really looking backwards and saying, have we been sustainable in this recent period? It's not looking forward and anticipating where are we going into the future. And so that's a limitation, a significant limitation of this approach. It also, for that reason, isn't really accounting for any potential biophysical limits or ecological thresholds that we may be surpassing in the future, or we may be on the path to surpassing. Finally, because we're just adding these values up, it makes the assumption that things are substitutable, that as we lose, for example, the exhaustible resources through extraction, we're in some sense making up for that through the increases in the manufactured capital. And that may be true to some extent, substitution may be possible, but at some point, once we reach these critical thresholds, we would no longer want to continue to make that same substitution patterns. So to answer the question, are Ohio's lands sustainable? Well, the simplistic answer would be no. We aren't meeting at least the strong sustainability limit or standard that we considered in terms of the 40% phosphorus reduction goal, nor are we maintaining the wealth from the natural capital stocks over time. And we looked at that section or subset of natural capital stocks in the inclusive wealth calculation. But as I emphasized before, this ignores trade-offs. And so when we do the inclusive wealth calculation as one way of accounting for these trade-offs, in other words, that we can substitute across different forms of capital, we do find that we are weakly sustainable. But there's some important caveats here. As I said, we're assuming substitutability and we're looking backwards rather than looking forwards. An advantage then of setting strong sustainability limits is it does give us a safety first approach, and that is advantageous given the substantial uncertainty regarding some of these biophysical limits, as well as the irreversibility of changes once we surpass those limits. And so this leads us to think about how could we come up with a more comprehensive assessment of sustainability. We call this a weak sustainability plus approach, in which we're tracking inclusive wealth on a very regular, if not continuous, calculations of inclusive wealth to try to assess the path that we're on. And we're holding to a weekly sustainable rule, which is non-declining inclusive wealth. In addition to that, we're adding strong sustainability limits as needed. So you can think of this as, for example, if there are limits in terms of carbon emission reduction goals or phosphorus reduction goals, these would be the strong limits that we would be adding as needed. The add needed part meaning that as we are approaching critical thresholds, we would turn these strong sustainability limits on. And this is an approach that we first talked about with some of my colleagues, Satya Gopalakrishnan and Alan Randall, both in AEDE, Alan's now emeritus, in an article we had a few years back on welfare, wealth, and sustainability. It's also something that we're exploring in our current NSF project on food, energy, and water systems in the Great Lakes region. And so it goes something like this. We would maintain inclusive wealth using a weak sustainability rule, and we would make sure that we have policies in place that are guaranteeing that as we progress in terms of using our natural capital or preserving it, that we are always maintaining a constant or increasing value of inclusive wealth. But then we would incorporate strong sustainability limits as needed. So for example, critical natural capital stocks, critical stocks of forest, or critical stocks of wetlands that help to absorb the pollutants and the nutrients before they enter into Lake Erie, for example. Critical limits on emissions and pollutions in terms of carbon emissions or phosphorus emissions. And we would want to be very parsimonious with these strong sustainability limits and make sure that we were not being overly burdensome, but really paying attention to where these ecological thresholds may be, where we may be approaching them and entering dangerous territory. On that basis, we would then identify potential policies. These might be regulations, voluntary incentives, community initiatives, or corporate actions that will help to ensure that we're both weekly sustainable as well as meeting our strong sustainability limits. And we would constantly assess the potential trade-offs. As these policies or potential policies are considered, what are the trade-offs across social, economic, and environmental outcomes, across different people, across communities, across different sectors of the economy, and of course, over time. And we would make adjustments to those policies on the basis of these trade-offs. Perhaps we're trading off too much of the economic gains in protection of the environment, or perhaps we're unintendedly creating social inequities through our environmental protection regulations. Whatever the case may be, we would want to be assessing those potential trade-offs and making adjustments to policies on that basis. And so it's an iterative process by which we're adjusting policies to maintain inclusive wealth, we're enforcing strong sustainability limits as needed, we're identifying policies that can achieve our goals, and always assessing the potential trade-offs of those policies. And in so doing, we get to the weak sustainability plus approach to sustainable development. Let me leave you with some challenges and takeaways. First of all, it's important to recognize that when we set strong sustainability limits, they're not just informed by biophysical realities. They're still implying trade-offs, and then we still need human judgment and values, morals and ethics in order to make these judgments. When we set, for example, carbon emissions target to reach net zero emissions by 2050, so that we try not to exceed 1.5 degrees Celsius global warming above pre-industrial levels, or we choose not to implement the policies to try to do this, these, in essence, are ethical decisions, and we're making trade-offs implicitly or explicitly in terms of what the impacts are going to be and the trade-offs are across current and future generations. For example, we seem to be well along the road to accepting the global collapse of the coral reefs. That's an ethical decision that we've made implicitly, if not explicitly. And so how should we determine these limits? They should be determined by ethical judgments but also by the degree of uncertainty. The more uncertain something is, the more we might want to impose a strong sustainability limit, particularly in the case of critical natural capital stocks. And of course, these strong sustainability limits will change over time with technology and information, beliefs, and values as these things change. The second point is that assessing the sustainability of an open region or state is tricky. By open, what I mean is, unlike the global economy or the global society, when we think of the state of Ohio, we think of a region like Central Ohio. This is an open region. We have people and flows of goods and services crossing the border all the time. And so we have to account for these trade flows and flows of people, goods and services in our assessment of sustainability. And that's sometimes a tricky thing. I mean, so for example, what if a region is losing population, as the Great Lakes region and the state of Ohio is projected to do so over the next several decades? Does that necessarily mean that we are or aren't sustainable? The smaller the region, the less substitution is possible within that region. And so what does that mean from a strong and weak sustainability perspective? And finally, what's the region's role in meeting national or global sustainability goals? If we have a global goal of reducing carbon emissions by 45% by 2030, what is our role here in the state of Ohio or the Central Ohio Columbus region in meeting that global sustainability goal? Lastly, there's just lots of unresolved questions about how to address intra versus intergenerational equity. We've talked a lot about intergenerational equity, and that's what sustainability has focused on by and large, is the notion of equity across generations between current and future generations. But intra-generational equity, that is equity within the current generation or within future generations, is an equally important issue. And we do recognize that we need to invest in strategies to reduce current social inequities so that we can do better at maintaining and achieving intergenerational equity across time. The two are fundamentally linked. But how to do that is really an unresolved set of questions around policies and strategies to do that. I'll stop there, and I thank you very much for your attention.
Hi everyone, my name is Ziqian Gong, and today I will introduce the modeling framework to you. In the model, our research area will be the Great Lake area, which includes Wisconsin, Illinois, Indiana, Ohio, and Michigan, because almost 40% of the land is crossed in the Great Lake area. Moreover, the Great Lakes also account for 5% of global freshwater. 10% of the region's exports are agricultural products. We will build the dynamic regional economic model of food, energy, water systems. Here, dynamic, it means we account for changes in the stocks of resources and goods over time, flow between different parts, both affect and are affected by the other parts in the model and also outside world. Then we will use it to analyze the environmental sustainability and individual well-being resulting from the changes in the economic and environmental systems. This model will represent the interaction between local, regional, national, and global systems across time and space. In the model, there will be a representative household and agricultural sector, manufacturing sector, energy sector. Specifically, we will separate the energy sector into renewable energy firms and fossil fuel-based energy firms. The renewable energy firms could receive the subsidy, and the fossil fuel-based energy firms may have to pay the carbon tax due to the regulation. Each sector in the model will be closely connected to other sectors. For example, On the one hand, the household will have to provide land, cattle, which can be used to buy the tractors and fertilizers to grow the crops. On the other hand, agricultural sector will provide food for the household, and all the sectors will connect to the ecosystem service through pollution. In order to solve our model, we will first maximize the utility, which is the satisfaction of the representative household in the social planner version. Then we will use the results from the social planner version to run our decentralized version, in which we will maximize the profit of each sector. As a result, the decision makers could use our results to help them maximize the potential of the Great Lakes economy and the environment to the benefit of its citizens.